Okay, hi, we're here today with Professor Jeff Morris of the City College of New York Chemical Engineering Department. Thank you for joining us, Jeff, and we'd like to hear something about your life in CCNY. So could you tell us a little bit about your historical trip to wind up here and doing what you do?
Well, thanks, Stu. Sure. Right, I came to City College in 2005, but I actually obtained my PhD in 1995, so there was a little period in between. In between, I spent a year as a postdoc. After a PhD at Caltech, I went to postdoc at Shell in Amsterdam. And there I was working on actually mostly refinery processes, although some people down the hall had encouraged me to work on some exploration projects looking at subsurface problems. And so that was a great time. That was in Amsterdam. After that, I taught at Georgia Tech, which was my alma mater for my bachelor's in chemical engineering. All my degrees are in chemical engineering, aside from a little bit of a minor in applied math. And so I went to Georgia Tech and taught in chemical engineering until about 2002, at which point I decided I wanted to get some industrial experience, and I went to work for Halliburton Energy Services. And so I was working on oil field problems, as people at Shell had suggested might be of interest for the area of work that I do, and we'll get to that in just a minute. But so I worked on various processes in the oil field for Halliburton. Of course, I did most of this in the lab, but I spent a number of days out working, looking at rigs and how they work in drilling. And so my area, that gets to my area of research, which is in particle-laden flows. And so there are just a wide range of particle-laden flows in the oil industry, as I'm sure you're well aware, Stu. And so I came to be aware of many of the things where in oil exploration and production there was value in this type of research. So after a couple of years, a position came open at the Levitch Institute at City College, and the Levitch Institute was very well known among my colleagues and me as a place that looked at the very basic issues in particle-laden flows as part of its general suite of questions. And so that was very appealing to me. My academic grandfather actually had been when I say that is my PhD advisor is my academic grandfather. That was Andy Akrivos, who was the advisor of John Brady, my advisor. He had been the director of the Levitch Institute, and I had visited a couple of times in the past and was very, very interested in work that was going on. So I applied for a position, and in January of 2005 I joined City College and have been here since. So that's the path that got me here.
Okay, and so now in the work that you do here now, can you tell us a little bit about what you and your students focus on?
Right, so my work is based on the area of suspension mechanics, really trying to understand how particle-laden fluids behave, and in particular how they behave in a way that is fundamentally different from pure fluids. So this ranges over a vast range of scales of particle sizes, from nanoparticles, dispersions, trying to understand protein solutions, up through trying to understand basically slurries of sand and water. And so the sort of the general features of that are that you have to worry about the fluid mechanical phenomena, but then you also have to understand what the other sets of forces are that the particles interact by. And so by having that interplay between the fluid mechanical forces and other forces, you come to an understanding of what's going on. And that really is I think, an example that is natural for the Levitch Institute, because overall what we're really interested in is this intersection of fluid mechanics and, let's say, physical chemistry, where the forces of particle surfaces or polymer chains or various other things play a role in physical, the fluid mechanical phenomena that take place. And that was something that Levitch worked on for a number of years himself. So Levitch was a Russian scientist who went to Israel and came to the United States in 1979, for those who are not well, he came to the United States in he left Russia in the Soviet Union at that time in 1975, went to Israel, and then came to City College in 1979.
So could you get more into the kind of work you students do? Is it a lot of theory of the calculations? Is it some measurements of these
Okay,
distinctions?
so very, very good. I got a little sidetracked, sorry about that. The research in our group is I would say about 50-50 experiments and simulations as opposed to really theory, although at present I have a jointly advised student who is doing some theoretical work. Theory is a difficult thing to promise as a student because, you know, it comes along now and then. But so we work with simulation tools whenever we can to try to understand phenomena, and the type of simulations that we do are ones where we study the discrete particle motions in the fluid and then put in the other forces, usually trying to understand what we call the rheology of the material. So that's the flow properties and why these materials have the characteristic behaviors that are different from a pure fluid. So you can think of things like sticky, gooey materials or pastes. So these are the types of materials that are of particular interest to us. And so that in natural systems includes mud or blood, because in each case you have a lot of particles, red blood cells in the case of blood, loaded up in a background liquid. And then when we simulate these, what we seek to understand is their properties and how those depend in a characteristic way on the forces. And also, something that is quite different from thermodynamics is that we try to understand how it depends on the driving forces in the system from the outside. So it's an area that's closely related to thermodynamics, but it's an area of statistical physics that's far from equilibrium.
So the students have a little bit of option of how much simulation, how much experiment they do, or is it fairly evenly divided with all of them?
I would say that it's, of course, a student in taking on a project has the opportunity to choose a project which is more suited to their own interests. But as they move along, they may choose to bring in more experiment if they see an opportunity to explore a phenomenon that's difficult to simulate. Or they can try to bring in a simulation where they see that they can probe these things. So every given project has its own natural balance that has to be satisfied because of the funding agency and how we've structured the project. But there is that opportunity to shift. We do encourage quite a lot of examination by analytical methods as a way to probe this area, but so much of the modern research in this area is driven by then carrying it to a computational framework if it's going to be non-experimental.
Right. Okay, and what's been your history with students that you have in terms of how have they adjusted to living in New York City, liking to go to a university in the middle of town like this? And all
well, I think typically students who come to City College, they probably have quite an interest in living in the city. New York City is unlike probably any other city in the United States, just in terms of the scale and intensity, but at the same time it's very neighborhood driven, and so here at City College we're in a sort of a right next to a leafy park, so there's that. But the students typically, I think, want to have the opportunity to do things that are unique to the city, both intellectually and culturally. So intellectually they have the opportunity to have interactions with neighboring universities within, on Manhattan. We have several other universities that we collaborate with, or we have students who've come from these places. That includes Columbia, NYU, Cooper Union, and then nearby, otherwise across the river in New Jersey, we have Rutgers and New Jersey Institute of Technology. Not far away we have Manhattan College, which is not on the island of Manhattan, although it started there long ago. It's actually in the Bronx. And so there's just a wide range of other universities. The other campuses of CUNY play a big role also, because there are collaborations with these other campuses, other facilities, and there's marvelous facilities available for research on the south end of the campus at City College, which are actually City University facilities known as the Advanced Science Research Center. So I think that these are the sort of the intellectual side of things, but then on the other side you have New York City, which has cultural opportunities, from museums to opera and various other things. Just the opportunity to see so many different ethnic groups, and to have opportunities. You can always think of the cuisines of different places, but those are just an entry point into the cultural life.
So these students often get to spend a few months or whatever in a different institute, or maybe even in a different country, or how does that work out?
Interestingly, I have a lot of connections with French universities, so I have a joint position with the CNRS over the next several years, and have in the past, and so we have made use of this as a way to have internships at a number of laboratories in France. So and other students go to other countries. Germany and Norway are associated with a program that we have now. Also, I've had students take internships in Australia, at U.S. National Labs, and various other places. So the collaborations that are local, typically people stay at home and just visit on a daily basis. But if you're going to go to Australia, you don't do that on a short-term basis. So that was a 6 or 7 month internship. I've also had a number of students go on to take internships while they're PhD students. So, for example, with personal care products is an area where that we've had interns go. Also to Corning, which is in upstate New York, is a company that I work with closely, and have former students there. So it's been a very nice place for people to go for internships. So the opportunity to do internships both industrially and with labs in other academic or national labs is something I think should be taken advantage of if it fits within the program for a student.
Good. And of students that have come through your lab and graduated, where typically do have some of them wound up?
Yeah, so a number of my students have gone into the petroleum extraction industry, and so that early on in my career, that was a place where a number went. Some others have gone into, for example, companies that do inkjet printing. I've had students who have gone to standard chemical operations. But because the work that I do involves trying to understand statistical phenomena and quite a large amount of computation, typically, at least for those who are doing simulations, there have been students who've gone into, unfortunately, I say unfortunately because we lost them to science, but they've gone into the finance industry. So I've had a couple that have gone into the finance industry, and I hope they remember me when they make a lot of money. But also a couple have gone into sort of the new realms of really trying to understand, getting into things like Google, and I have a student who's at Google, and others have gone into the startup area related to the environment. So that's the kind of a wide spectrum.
It is. It's a very wide spectrum of
right.
opportunities that they have.
Yeah, one area that is some have dabbled in is in the area of additive manufacturing, which is this new rapidly developing area, and particle-laden flows are a good way to lay down material in an additive manufacturing sense. So additive manufacturing can be done over extremely small scales where you're doing fine parts up to the scale where you're actually basically building buildings by inkjet printing them. It's just that the ink happens to be cement. So
I can see the day when we buy a house and it's just printed in a month or two.
well,
That
it's
would be
it's
really
it's
cool.
actually quite true that that's being done in large scale buildings.
Really?
It's less so in the United States and Western Europe, but in Asia there is some of this type of work where large scale essentially printing of the house by large nozzles is
that's
a very
amazing.
rapid way to build a structure.
That's cool.
Yeah.
Okay, so if I were a student that was considering coming to CCNY, Chemical Engineering, and considering potentially working in your group,
You coming back?
would you have some advice for me or comments about?
Well, I'd say just do it, but in all seriousness, the real advice would be always, of course, get as much background understanding as you can, and then make a visit. That's the first things. But really, I think it's important to visit to get a real flavor of what the people are like and how they interact with one another, because if you are considering a graduate degree, you're going to be spending a fair amount of time doing that, and you want the environment to be one where you're not just intellectually challenged, but also you feel comfortable. And I think that we do very well on this, but that's important for the individual student to see how they feel about it. We are a campus which is extremely diverse, and so we have people on this campus speaking, I believe it's over 90 different languages, and so there's really something very unique about City College in that regard. We, as a department of chemical engineering, and the Levitch Institute is involved in this as well, we really are collaborative and interactive, and so you have to get a sense of the different areas that work together and how they play a role in making something better than it could be if it was just one individual discipline. Now, trained as a chemical engineer, I think that we have a very nice, well-organized curriculum that can do a great number of things, but we can't solve all the world's problems alone. So
Right.
in particular in my group, I have students who come from mechanical engineering, chemical engineering, and physics backgrounds, all in the
Wow.
group at this point.
And the department itself, being it is relatively speaking fairly small compared to some of the big schools, there is at least what I've seen, a fairly collegial environment among the faculty and the students, and I think that can be quite helpful.
I certainly think so. I mean, I jointly advise, two of my PhD students are jointly advised, and with faculty members from both physics and chemical engineering, and so that's something that I think is very normal around here. It helps to broaden the base of understanding that builds into a project, and the collegiality in terms of the willingness to interact and help one another is, I think, extremely good. I don't think that that's necessarily unique here, but I think it's a very special way that we do that. We really try to make it possible for there to be large numbers of facilities that are shared among a broad range of faculty, which helps, especially if you want to try something new. You don't have to go out and buy a new piece of equipment. You don't have to go searching around. Go down the hall, talk to somebody who's expert in using it. So the effort is certainly there, and the spirit is great, and I find that our collegiality is a wonderful part of why I like working here.
Okay, great.
Mm-hmm.
So in sort of conclusion then, is there anything you would like to add that maybe we skipped over, or any advice, more advice to the students out there?
Well, I mean, I think that I would say that the City College has always really tried to advance intellectual effort has been a place which historically has brought people who are underserved into the academic community, and so we have done very well in this regard. But I think that there's a whole new generation out there that we really would like to engage in our efforts, and I think that what we do intellectually is at the very first rank, and at the same time what we do in terms of educating students and bringing them forward is marvelous. And so the combination of the educational program and the value of research come together here in a way which I think creates an intellectual environment which is rich, and so I think that that's something that should be seen. If you have a chance, come and visit us.
Okay. Okay, well, Professor Morris, thank you so much for spending time with us today, and appreciate all your wisdom.
Thank you, Stu. I appreciate it.